and now we're going to explore trig of any angle. And what I mean by any angle, we literally can take the trig function of any angle. Previously in geometry, you're pretty much restricted to your 36, your from 0 to 90 degrees exclusive because of the right triangles. And then we explored recently how to take, say, the sine or cosine of 150 degrees by using the reference angle right here of 30 degrees. And just keep in mind we're in quadrant 2. So in quadrant 2, your sine is going to be positive and your cosine is going to be negative. So using reference angles is actually pretty good a deal. But on our unit circle, we're pretty much limited to reference angles that turn into our special right triangles. What happens if we wanted to find the trig functions or identities or whatever associated with this coordinate right here, whatever that may be? So I'm going to show you how we can do that. Now remember, unit circle is just a circle with the radius of 1, but we can dilate that and find other things. So let's say we're going to find the trig of any angle, but we're given the coordinate and we don't know what theta exactly is. We can find it. So what I'm going to do is I'm going to go ahead and sketch this, and it could be an ugly sketch. And I'm going to have -3, 4 as my coordinate. So -3, 4. So I have a point right over here of -3, 4. What I want to do is go ahead and figure out how to work this by dropping the altitude and creating a hypotenuse that we don't know what it is. So this is my delta x, which is -3. Okay. So this length is actually delta x is equal to 3. That's length. Okay, lengths are positive. Delta y is 4. So we're going to have a squared plus b squared equals c squared. And that will give me a 5 because this is a 3, 4, 5 Pythagorean triple. So now that I have this, and this is my theta reference, I can find my sine cosine. Sine of theta is equal to 4 over 5. Cosine of theta is equal to 3 over 5. Tangent of theta is equal to opposite over adjacent, so 4 over 3. And of course we have our reciprocal functions, 5 over 4, our secant, which is 5 over 3, and our cotangent, which is equal to 3 over 4. Okay? Now the key is that radius is going to be positive. So if we wanted to find what the theta was, we could do the inverse. Okay? And this is going to give us the reference angle. Okay? This is reference angle. This is the reference angle. Okay? Because our actual angle may be any coterminal angle, because this is my terminal side, this is my initial side. So I could actually put a little apostrophe there and consider this as my theta. And we could do the inverse functions of that. I don't have my calculator handy. Actually, it's just standing right over here. I can easily find it, but that's not too important for this lesson right now. So let's go ahead and take a look at this. I'm going to say, okay, I'm going to do, let's pick something in quadrant 4. Okay? So I'm going to do, let's say, -2, -3. Sounds like a good one right there. So I'm going to do -2 and -3. So here's my point right here. I'm going to go ahead and draw my hypotenuse, finish my triangle right here, and we want to find my reference angle here. So I don't know what this is, or I could go around 360 degrees, 720 degrees. We have unlimited choices for coterminal angles that we can find on theta. But let's just find our reference angle of theta and our 6 trig functions. Well, if this is going to be -2, 3, -2, -3, my delta x is going to be 2. My delta y is equal to 3. And using the Pythagorean theorem, 2 squared plus 3 squared is equal to c squared, or r squared. That's 4 plus 9 is equal to c squared, so c or r is equal to square root of 13. Okay? And then we would go ahead and do my sine of theta is equal to, because that's going to be root 13 right here. I can make it a little prettier. So this is going to be 3 over root 13. And we practice this in class, so hopefully you can do these in your head. And root 13 is actually pretty easy to work with. 3 root 13 over 13. Okay? Cosine of theta is going to be adjacent over that, so 2 over root 13, which is equal to 2 root 13 over 13. Tangent of theta, opposite over adjacent, 3 over 2. And of course my reciprocals are just going to be flipping that. I don't need to flip that because I'd have to rework the diamond. I'm just going to get root 13 over 3. Secant of theta is going to be root 13 over 2. And cotangent of theta is equal to 2/3. Pretty easy, straightforward stuff. And I can actually find what this reference angle is by doing the inverse function. Just plug it into your calculator and you got it. Alrighty, I'll go ahead and get this posted and move on to our next topics.